What's up, everybody? Got another video here for you. Here's a nice one right here. It says use cylindrical coordinates to find the volume of the solid that lies within the sphere x squared plus y squared plus z squared equals 25 above the xy plane and outside the cone z equals 2 times the square root of x squared plus y squared. All right, so I think the best way to start this is maybe sketching and seeing what we got here. Let's see. All right, so where do we want to draw that? Let's draw it over here, and let's draw it in a lighter color. All right. So I guess we can maybe draw our sphere first. That's going to look something like this. And it's going to be the upper half of the sphere, because notice it's that lies within the sphere but above the xy plane, so we're not going to have the whole thing. We got the hemisphere up here. And then we got the cone. Well, the cone's going to come up like this. So you got a cone coming up. It's going to go up through there like this. Okay. And I mean, you can see it's going to intersect like right in here. The cone will. All right. That's where it would intersect the. Well, let's not draw that. Well, I guess we really need that. All right. So, what do we have to do here? Well, let's get the sphere. Now let me change colors again. Let's take the sphere x squared plus y squared plus z squared equals 25. And this is the sphere. And then let's take the cone, which is z equals 2 square root of x squared plus y squared. And let's get these, let's rewrite these things. We can rewrite the sphere as what? R squared plus z squared equals 25, and we can write this as z equals 2 times r, right? So if we solve each of these for r, that is going to give us, let's see, that's going to give us r squared is equal to 25 minus z squared, and here r is equal to the square root of 25 minus z squared. That's the top half of the sphere, because remember we're converting to cylindrical coordinates. And then here we get r is equal to z over 2. So just notice when we set this up, okay, when we set our volume up, I'm going to write that down here. That's going to be, we're going to have a triple integral. All right, a triple integral. And remember, since we're finding the volume, it's going to be 1 times what? 1 times r dr dz d theta, right? When we go to cylindrical coordinates. All right, so now we need r. What's r? Well, that is going to be the distance from here to here, from the cone out to the sphere. Okay, so can you see in this one that r is between what? Z over 2 and square root of 25 minus r squared. Okay, I'm sorry, minus z squared. Okay, that's what r's between. We're going from the cone, which is this, out to the sphere, which is this. All right. That's R right there. All right. So our bounds here, that's going to be z over 2 to square root of 25 minus z squared. All right. And I'm going to erase this 1 here. Okay. Because, I mean, 1 times r is r. All right. Now we need to know the bounds for z. So we know that z is going to go from 0, because we're going from the xy plane up to this point right here. See, this is going to be z. It's going from 0 to some value up here. Okay. So how are we going to go about finding that? Well, that's where the cone and the sphere intersect. So we could set this equal to this and solve for z. That'll give us the z value where they intersect. All right. So now let's write, let's come over here and do it. Let's do z over 2 is equal to square root of 25 minus z squared. So we square both sides. That's going to give us z squared over 4 equals 25 minus z squared. And so that's going to give us z squared equals 100 minus 4z squared. So we move that over. That's going to be 5z squared. Divide by 5. 100 divided by 5 is 20. So that's going to be z is equal to the square root of 20. All right. So we're going up to the square root of 20. And then theta, well, if you imagine looking at it from the top or something, we're going all the way around, right? For theta, we're not just going halfway around. The cone goes all the way around. The sphere goes all the way around. And so here we're going from 0 to 2 pi. See, if we look down on it, you're going to see something like this. And so you can see theta, we're going all the way around like that. And so that's going from 0 to 2 pi. All right. All right. So now all that's left to do is to integrate this thing. All right. So let's do it. So we've got 0 to 2 pi, 0 to square root of 20 is equal to 1/2 r squared. And r is going from z over 2 to square root of 25 minus z squared. And then that's going to be dz d theta. All right. And I just hope I don't make a stupid mistake somewhere and just throw this whole thing off. But anyway, we'll be all right. We'll take our time. Whoop, look there. I almost left off the square root. All right, so this is going to be 1/2 times, and that's going to be square root of 25 minus z squared minus z over 2 squared dz d theta. And what I would suggest here, when you're working problems like this, write every little thing out. Don't leave out anything. Just write all the little details out, because I'm telling you, if you don't, you're going to end up screwing something up. You're going to make a careless mistake somewhere. So we got 0 to 2 pi, and watch, now that I said that, I'll probably screw it up somewhere. All right, so we got 25 minus z squared minus z squared over 4 dz d theta. And so, like I said, I'm just going to take my time. 0 to square root of 20, that's 1/2 times, and that's going to be 25 minus 5/4 z squared dz d theta. Okay. I just added those two fractions there. All right, so now I've got 0 to 2 pi, 0 to square root of 20. Let's go ahead and distribute that 1/2. So that's 25 over 2 minus 5/8 z squared, and that's going to be dz d theta. All right. All right, so now, well, look at this. You see, we've got this. So what we can do is we can go 0 to 2 pi. We can split these integrals up. And that's going to be 25 over 2 minus 5/8 z squared dz. All right, so now let's just integrate each one. Well, this one, that's theta, and then 2 pi minus 0 is 2 pi, so we know that's 2 pi. If you're in Calc 3 or 4, whichever one you're taking, I know some schools just go to Calc 3, some go to Calc 4. It's the multivariable calculus. If you're in that, you probably already know that's 2 pi. All right, and then this is going to be times 25 over 2z minus 5 over 24 z cubed. Z equals 0 to z equals square root of 20. All right, and so that's going to give us 2 pi times, and that's going to be 25 over 2 square root of 20 minus 5 over 24 square root of 20 cubed. All right, and then you punch that into your calculator, you're going to get 234.160491, and that would be your answer. All right, so not really that bad of a problem. Cylindrical coordinates made it a little easier for us to integrate. You can also set this up with spherical coordinates. I may do another video on this same problem using spherical coordinates, and you can see the difference. But I hope you enjoyed that video. I hope you learned something. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.